we can look at cube root functions. A cube root function is where the index is a 3, such that the cube root of a equals some b, which also means that b cubed equals a. An example that we could show where that would be the case is maybe a 3 or a cube root of 64. What times itself, or what times itself 3 times produces a 64? That would be a 4, because 4 times 4 times 4 equals a 64. We'd also look at the cube root of negative 27. Yeah, you're right. There's a negative inside this time. Is it defined? It is, because what times itself 3 times produces a negative 27? That would be a negative 3. Because we can go negative 3 times negative 3 times negative 3 produces a negative 27. So what that tells us is that our domain is not restricted by negative numbers. And it also tells us that we have a function developing such that f of x equals the cube root of x. And let's graph that out a little bit to see what that graph would look like. We'll draw a rough or plane right there. 1, 2, 4, 2, 3, 4, 9. Notice it's not quite to scale, so I apologize for that. Some of the values we know. If x were a 1, we know its cube root, or its cube root is also 1. If x were the next one, 1, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Its cube root is a 2. Likewise, if x were a negative 1, its cube root would be negative 1. And if x were a negative 8, it would be a negative 2. So I start to build a little bit of a graph similar to that type of an idea that shows that we're a function. It also shows that my domain is a set of all real numbers. So domain equals all real numbers, or in interval notation, negative infinity to positive infinity is my set, or is my domain. So we're going to look at exploring how to work with some functions and evaluate these.